All right, so if you could turn to page 7 of your packet, we're going to just talk about normal distributions and z-scores. So let's just first talk about normal distributions. It says really right here, normal distribution is approximately symmetric and mound-shaped. So what you can see right here. Okay, so number 1 says determine whether each of the following distributions are normal. So if we look at this first one here, you could see that this is approximately symmetric and it's mound-shaped. So this one definitely would be. So I'm going to say yes. And you can just say because it is approximately symmetric and mound-shaped. You can just give the definition. Sorry, it's hard to write with this. It's a little messy. All right, if you take a look at the letter B, this one's definitely not a normal distribution. This is not symmetric. You could see right here that this is skewed to the right. So this right here would be no. And explanation, you could say it's skewed right. Okay, it's skewed right, so it is not symmetric. And when I say it's not symmetric, I mean that, you know, if I were to, let's say, kind of fold this in half here, the left half of our histogram doesn't approximately fold onto the right half of our histogram, whereas if you look at letter A, you could see that the left half would approximately fold right on top of the right half. All right, letter C. This one, although it is approximately symmetric, the left half is approximately symmetric with the right half. It's definitely not mound-shaped, so I would say no for this one as well. And you could say, although it's approximately symmetric, it is not mound-shaped. Okay, so this is really what I want to get at through this video, z-scores. Now, we talked about in class what a normal distribution is and how approximately 68% of the scores are within one standard deviation of the mean, and approximately 95% of the scores are within 2 standard deviations of the mean. Now, sometimes a score may not fall exactly 1 standard deviation above the mean or exactly 2 standard deviations below the mean. So what we do is we use this formula right here, and this formula helps us find a z-score. And a z-score just measures the number of standard deviations that your score or your data point is away from the mean. All right, so let me just jump right into it so you can see what I mean here. Number 2, it says the prices of printers in a store have a mean of $240 and a standard deviation of $50. Okay, the printer that you eventually choose costs $340. What is the z-score for the price of your printer? All right, so if we use our formula right here where it says, you know, in this box here, it says z equals value. So the value is going to be the value of the printer, which is $340. And then it says minus the mean. So when we read the problem, it says it has a mean of $240. So we'll subtract 240 from that. And we want to divide by the standard deviation. And when we read the problem, it says the standard deviation is $50. So 340 minus 240 is 100. And 100 divided by 50 is 2. So the price of our printer, since the z-score is 2, the price of our printer is exactly 2 standard deviations above the mean. So if we were looking at, you know, the normal distribution curve that we talked about yesterday, here's where our mean is, and this would be 1 standard deviation above the mean, and this would be 2 standard deviations above the mean. So the price of our printer falls exactly 2 standard deviations above the mean. Okay, so if you turn the page to page 8, you'll see number 3 says, Ashisha's height is 63 inches. The mean height for boys at his school is 68.1 inches. So the mean is 68.1 inches. And the standard deviation of boys' heights is 2.8 inches. Okay, what is the z-score for Ashisha's height? And this time they asked us to round to the nearest hundredth, because it's not always going to be a nice clean answer like it was in the last example. All right, so let's do this. Z-score is equal to value minus mean over the standard deviation. Okay, so Ashisha's height, the z-score associated with that. So we're going to do value, which the value of his height is 63. From that, we're going to subtract the mean, which they told us is 68.1. And we're going to divide that by the standard deviation, which they said was 2.8. So 63 minus 68.1 would be negative 5.1. And when we divide that by 2.8, it says to round to the nearest hundredth. So if you plug that in your calculator to the nearest hundredth, we would get negative 1.82. So this is the z-score that's associated with Ashisha's height. So if you just thought about the normal distribution curve, okay, this right here is our mean, which we know is 68.1 inches. Okay, that's the average height for boys at a school. If we were to go one standard deviation down, we would basically subtract the 2.8 from the 68.1. If we were to go 2 standard deviations down, we would subtract another standard deviation. We would subtract another 2.8 from that. But his z-score falls right about here. Okay? It falls at 1.82 standard deviations below the mean. Okay, so he's, below average in height. All right, so when it says in part B, what is the meaning of this value, you could just write out Hashisha's height is approximately 1.82 standard deviations below the mean. So Ashisha's height is, I'm going to say approximately because it's a rounded value, 1.82 inches below the mean. And again, I'm saying below because we have a negative value. All right, so if you turn to the next page, we're going to use z-scores to help us find the probability of something occurring. Okay, so number 4, it says, a swimmer named Amy specializes in the 50-meter backstroke. In competition, her mean time for the event is 39.7 seconds. I'm just going to underline that. So her mean is 39.7 seconds. And the standard deviation of her times is 2.3 seconds. Okay, assume that Amy's times are approximately normally distributed. All right, letter A says, using z-scores and a graphing calculator, rounding your answers to the nearest thousandth. I'm just going to underline that so we don't forget to do that. Find the probability that Amy's time in her next race is between 37 and 44 seconds. Okay, so the first thing we have to do is we have to determine the z-score that goes along with 37 seconds, and then we need to find the z-score that goes along with 44 seconds, and then we're going to use our calculator to find the probability of this event occurring. Okay, now because we're finding 2 different z-scores, I like to just label which is which, so I'm going to find the z-score that goes along with 37. I just write that z sub 37, and then I'm also going to find the z-score that goes along with 44, which I write as z sub 44. Okay, so let's see. If we're going to, let's start off with this one right here, z sub 37. So we want to do value. I'm not going to write out the formula anymore, but we do value, which in this case is 37, minus mean, which we know is right here, 39.7 seconds, divided by, and the standard deviation, which is 2.3. Now, we are going to have to do a little bit of rounding here. So this is what I'm going to have you guys do whenever you use z-scores. When you subtract these two numbers and divide by the standard deviation, I'd like you to write down what that's equal to, rounded to the nearest 10,000th, so the nearest 4 decimal places. So I'm going to write that. When I plug that in my calculator, I get negative 1.1739. Okay, so that's the z-score that goes along with 37. 37 is exactly, or I'm sorry, is approximately 1.1739 standard deviations below the mean. Okay, so now we're going to do the same thing with the 44. So this time, our value is 44, and I'm going to subtract the mean from that, which again is 39.7, and I'm going to divide that by the standard deviation, which is again is 2.3. And when I plug that in my calculator, I get 1.8696 to the nearest 10,000. Okay, so just to kind of look at what this means, if we want to find the probability that her next race is between these times, well, if you just kind of visualize the normal distribution curve, okay, here's Amy's mean race time, and so let's just put 39.7 up there, and you know, if you were to have, let's say, 1 standard deviation below, 2 standard deviations below, 1 standard deviation above, 2 standard deviations above, this score right here falls approximately 1.1739 standard deviations below the mean. So that would fall, I don't know, right about here. Let me make that another color. Okay, so that's where 37 would be. It's below her mean time. And then 44 seconds would fall approximately 1.8696 above the mean, so figure it would be somewhere like up over here. So that's where 44 would lie. If we want to find the probability that she gets between these scores, we're trying to figure out what percent of the curve falls in between these two numbers. Okay, now we're gonna, because it's not, you know, an exact value on the bottom of our normal distribution curve here, we're going to have to use our calculators to do this. And the calculators do it 2 different ways. So you're going to have to try this in your calculator and see which way your calculator does it. I'm going to kind of give you a screenshot of what it looks like. Okay, so first thing, take out your calculator, and you want to go to where, you want to go to second vars. Here, I'm going to actually write this down. So in your calculator, you want to hit the second button, and then you want to go to vars, which is actually just to the left of the clear button. Okay, and above that it says distribution. So that's really what we're trying to go into, distribution. Okay, so when you hit second vars, you're going to go down to the second choice, which says normal CDF. Okay, and at this point, your calculator is going to show one of 2 things. Okay, so if your calculator, when you click on normal CDF, looks like this, all we're going to do is we're going to insert what we call the lower bound, which is that negative 1.1739. You're just going to plug it right in, and then you're going to put a comma. The comma is right above the 7, and then you're going to plug in the upper bound, which is 1.8696. So you can't see the whole thing on the screen, but it's going to look like this, and then just hit enter. And when you do, this is what you'll see. And this number right here is the probability that it'll fall between those 2 scores. So they want you to round to the nearest thousand, so 0.849. So basically there's like an 84.9% chance that her next time, her next race, will fall between 37 and 44 seconds. Okay, now let me show you if your calculator does it the other way. Okay, so going back when we hit second vars and went down to choice 2, which is normal CDF, if this is what your calculator looks like, you'll see it says lower bound. This is actually what, this is the calculator, the model I use. It says lower bound, upper bound. Don't even worry about these. These we're always going to leave this at 0 and this at 1. But what I want you guys to do is I want you to take that lower bound, that lower z-score that went along with the 37 seconds and put it where it says lower. And I want you to take that higher z-score, that bigger z-score, which we call our upper bound, and I'd like you to plug that into where it says upper. And then just highlight pace, scroll down to pace, and hit enter. When you do, you'll see this on your screen, and then just hit enter again. And you should see the exact same thing that the other version of the calculator showed. So again, this number right down here, this is the probability that her race will be between 37 and 44 seconds. Okay, so just to kind of finish showing this work on your paper, this is all I want you to write out. So this right here, what I'm kind of putting in this red little cloud, you don't have to show that. That's just for your notes. But what I do want you to write is when we went to normal CDF in the calculator, then you open a parenthesis, you could say this was my lower bound, comma, this was my upper bound. And the problem, again, did want us to round to the nearest thousandth, and we wound up getting 0.849. So there's a really good chance, I didn't really circle the number. So there's a really good chance that she will score between 37 and 44 seconds in her next race. Okay, so we're going to try part B and part C of this question together, and then you guys are going to try the next few pages on your own. All right, so part B, it says, it's still the same situation about Amy the swimmer. It says using z-scores and a graphing calculator and rounding your answer to the nearest thousandth again, so we're just going to underline that again. Find the probability that Amy's time in her next race is more than 45 seconds. Okay, now if we want more than 45 seconds, we really only have to find one z-score. Because if you think about it, I'm just going to kind of draw out the normal distribution curve, right? If her mean time is 39.7, figure 45 seconds is going to be somewhere up here above the mean. If we want to find the probability that her race is more than 45 seconds, we're looking for all of these percentages that fall above 45 seconds. Okay, so we really just want to find this z-score, and then I'll kind of show you what to do from there. All right, so we're finding, if you want, you can always put the little subscript down with the z if that helps you out. If you want to write z sub 45, you can. All right, so if we're using our formula, we're doing value minus mean. The mean is the same thing it was in part A, so 39.7, and then divided by the standard deviation, which again is 2.3. When you plug that in your calculator to the nearest 4 decimal places, we get 2.3043. Okay, so this time of 45 seconds falls approximately 2.3043 standard deviations above the mean. Okay, so now what we're going to do is we're going to do kind of like what we did with the last one. We're going to go to normal CDF in our calculator. And we're going to need to include a lower bound as well as an upper bound. Now, if you look, this z-score is our lower bound because we want to figure out the probability that we start here and look at all the times above it. So we're going to use that 2.3043 as our lower bound. And as an upper bound, you can really just use any big number. A rule of thumb that most people use is they just use 9999. Okay, so whenever you're, making your upper bound a big number, that's usually what I use. I mean, if you want to use like 7777, go for it. You're going to get the same thing in the end. All right, so let's go into our calculator. I'm going to kind of do this with you. So we're going to go to second bars. You're going to go down to number 2, which is normal CDF. And if your calculator, just opens up a parentheses, if it opens up a parenthesis for you, you're just going to plug in this number, comma, 9999, and then close the parenthesis if you want. It doesn't really matter if it's at the end of the expression, and hit enter. If your calculator has that screen where it says lower ... just plug in this for your lower bound, and then it says upper. You're going to plug in this for your upper bound, and then scroll down to paste. And when you do, you can hit enter, and to the nearest thousandth, I'm getting 0.011. So this is equal to 0.011. So there's not really a good chance that she's going to get, that's a lower probability. I mean, if you move the decimal place over twice, it's only a little more than 1%. So, and you can see that's where our curve is really low. There's not many scores or many, times that would fall above that. So that's why we got a low number here. All right, and then finally, let's take a look at letter C. Letter C, same situation. We just want to figure out the probability that her race is less than 36 seconds. And again, they want us to round to the nearest thousandth. All right, so let's find the z-score that goes along with 36 seconds. So we'll do value minus that same mean divided by that same standard deviation. And when we do, we get negative 1.6087. So again, if you visually want to think about where this would fall on the normal distribution curve, okay, here's our mean. This time of 36 seconds is going to fall approximately 1.6087 standard deviations below the mean. So if we want to find the probability that her next race time is less than 36 seconds, we want everything to the left of this number right here. So we really want everything between, a really small z-score and this z-score, which is going to be our upper bound. So when we do normal CDF in our calculator, our lower bound needs to be, now some really small number. Now, before, when we use positive 9999 for our big number, we can use negative 9999 as our lower bound. Okay, so this is going to be our lower bound. And then our upper bound is going to be this right here, because we want everything up until 36 seconds. So we're going to make our upper bound negative 1.6087. Okay, so in the calculator again, go to second bars, scroll down till you see normal CDF, choice 2, and our plug in your lower bound, plug in your upper bound, and when you do, you get 0.054. Okay, so there's approximately a 5.4% chance that her race time will be less than 36 seconds. All right, so now what I want you to try right now on your own is, let's see, page 10, 11, and 12. And we will go over that in our next class. I think on page 10, it's really similar to what we just did. Page 11 isn't so bad. Number 12, part A isn't bad, but part B is a little tricky. So see what you could do with that.